This lesson we're looking at making predictions using a linear model. So let's have a look at this linear model here. All these blue dots are our original data. So this is given to us, and based off of this blue dot, we draw a line of best fit. Now, using this line of best fit, we can make some predictions. We can make predictions of a value here, which originally didn't exist, just using our original data with the blue dots. But now we can sort of make a prediction of what they would be based off of the linear line that we just found out. Now, if we're making predictions like these, which are within the data that's given to us, so our data starts here, this x value, and it ends here. That's the highest original data that we have. But because our linear line goes off of this region, so the line goes on forever, so we can make a prediction over here, we can make a prediction here or here. So it gives us the power to make predictions outside of our data as well. But because our linear line is based off of the data that's given to us within here, the predictions that we make inside of this region, we call it interpolation. They are going to be more accurate prediction compared to the predictions we make outside of our given data. And these predictions that we make, we call it extrapolation. So that's the ones outside of the data. So let's look at some examples here. So this data is about age and height for Clara, and it's measured on the 10th, 12th, and the 14th birthday. So the data that's given to us is 1 on 10th, 1 on 12th, and 1 on the 14th. And based off of these three data points, we draw a line of best fit, which is just here. So even though we're not given the data of her height on her 13th birthday, using this line of best fit, we can make a prediction. And to do that, we'll just have to read off what the height is when she's 13 years old on this graph. And you can see that's going to be roughly 156. So this double squiggly line represents an approximation. So it's not actually equal to 156, but roughly around that point. And this is a interpolation because we're making a prediction within the data that's given to us. The data that's given to us starts at when she's 10 and it ends at when she's 14. So any predictions we make within this years is going to be an interpolation. Now, if we make a prediction of a height on her 15th birthday, which we can do, and it's just around here, and the value for that is roughly 170, so it's going to be roughly 170 centimeters. Because it's outside of the data that's given to us originally, we call this extrapolation, and it's not as accurate as the prediction we made using interpolation. All right, this next example here, we're shooting a rocket, and when time was 0, so at the very start, it was obviously stationary, and then after you shoot it, after 10 seconds, the rocket was traveling at 150 meters per second. And this data can be modeled by this equation. This means that it's done all the hard work of figuring out, all the data points and then drawing a line of best fit. And the equation of this line of best fit between our time and velocity is v equals 15t. So that's the equation of the line of best fit that's given to us. Using this equation, we can make a prediction of the speed, the velocity of the rocket 8 seconds after the launch. To do that, we'll, instead of using t, we will put 8 there because t represents seconds. So whatever this is, and that should be 120, and our units is meters per second, so meters per second. That's the answer for that one. The next question asks, is this interpolation or extrapolation? The question we just answered. So we need to think about what data this was given to us. So we measured from when time was 0 seconds to all the way to 10 seconds. So anywhere between 0 to 10 seconds for time is within our data. So this is an interpolation because it was 8 seconds. Alright, and the last question says an estimation made at 5 seconds is more reliable than an estimation made at 12 seconds. True or false? Again, because our data range that we made this equation based off of is going from 0 to 10. So anything within that is interpolation, making it more reliable, more accurate. So an estimation made at 5 seconds is going to be more reliable given that it's an interpolation, and estimation made at 12 seconds is going to be less reliable given that it's an extrapolation is your answer for that one.